Trigonometry, Chapter 1, Trigonometric Functions, Section 4, Using Definitions of Trig Functions, Video 7, Domain and Range of Secant and Cosecant. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous videos, we discussed the domains and ranges of sine, cosine, tangent, and cotangent. We derived our results analytically by examining the definitions of each. In this video, we discuss the domains and ranges of the last two trig functions, secant and cosecant. Recall that for an angle theta, with the point xy not equal to the origin on the terminal side, we have secant of theta equals r over x and cosecant of theta equals r over y. Wait. We are encountering the exact same issues that we had with the domains of tangent and cotangent. Now, what do I mean by that? Well, the denominator of both tangent and secant is x, and hence their domains exclude the same angles, namely angles whose coterminal side has a point where x is equal to 0, aka the y-axis. And similarly, the denominator of both cotangent and cosecant is y, and hence their domains exclude the same angles, namely angles whose terminal sides contain points whose y-coordinate is 0, aka angles whose terminal sides are on the x-axis. So we could just add each secant and cosecant below the function that has the same domain. We can add secant below tangent, cosecant below cotangent, and just copy and paste the domains, which I literally did. Just remember that it's easier to think about the domains in terms of the axis on which the terminal side terminates. Tangent and secant, the domain is all angles except those whose terminal side is on the y-axis. Cotangent and cosecant, all angles except those whose terminal side is on the x-axis. But what about ranges? Well, to determine the range of secant theta, we will use the range of cosine theta and capitalize on the reciprocal relationship between cosine theta and secant theta. Recall the range of cosine theta is the closed interval -1 to 1. Closed meaning it includes the endpoints. In order to algebraically deduce the range of secant theta, we will write this interval as a compound inequality. So -1 is less than or equal to cosine, which is less than or equal to 1. Now, secant being the reciprocal of cosine is undefined when cosine of theta is equal to 0. And because of this, we will split the range at 0 and have two separate inequalities. The first of which is -1 is less than or equal to cosine theta, which is less than 0. The second of which is 0 is less than cosine theta, which is less than or equal to 1. And we will analyze the positive values of cosine theta first. So we'll just look at 0 is less than cosine theta is less than or equal to 1. Now, how are we going to get secant out of this? Well, let's get secant into it first. Let's replace cosine theta with 1 over secant right in the middle. And to get secant out of the denominator, we're going to multiply everything by secant theta. But since cosine of theta was positive, so is secant theta. Thus, multiplying by secant theta preserves the inequalities. Don't turn any signs around. Multiply everything by secant of theta. The left stays 0, the middle becomes 1, the right becomes secant theta, like this. And right away, we can see that this part of the range for secant of theta is the closed interval from 1 to infinity. But we have the other half to deal with also. Next, we'll analyze the inequality for negative values of cosine theta. -1 is less than or equal to cosine theta is less than 0. We're pretty much going to do the same thing, but we have to be aware that we're going to be flipping signs because we'll be multiplying by negative values. We're going to replace cosine of theta with 1 over secant theta, and we're going to multiply everything by secant theta again. But since cosine theta is negative, so is secant theta because it's the reciprocal. Thus, multiplying by secant theta reverses the inequalities. Watch closely as I multiply by secant theta, and all the less thans become greater thans. Just like that. And then we clean everything up, and we end up getting negative secant theta is greater than or equal to 1, which is greater than 0. But we want to know about secant theta, not negative secant theta. So we need to fix the negative. So we multiply everything by -1. But this will reverse the signs again. So the secant theta will become positive, the 1 will become negative, 0 will stay the same, and all the signs will turn around, and it looks like that. And this gives us the other half of the range of secant of theta. It's from negative infinity to negative 1, closed on the negative 1. And because our two parts of the range are non-overlapping intervals, we join them into a single set using the symbol for union, and so our range for secant of theta looks like this. From negative infinity to negative 1, including negative 1, union 1 to infinity, including 1. Since the range of sine is the same as the range of cosine, the range of cosecant ends up being the same as the range of secant. This completes our table. And there it is. Now you try. Pause the video and try the following. Which of these are not in the domains of secant or cosecant? And which of the following are in the range of secant and cosecant? Here's your fair warning. If you haven't paused the video to try yet, solutions in 3, 2, 1.